NeuroGlancer is an open source web-based application for viewing volumetric data. It also supports meshes, skeletons, different types of annotations. It's entirely a client-side application. So in this case, I'm loading this application from a server, but that server is just providing the HTML and JavaScript. There's no server-side API required to use NeuroGlancer. NeuroGlancer will just retrieve data sources in various formats from existing web servers or cloud storage directly. I'll just give a brief demo of NeuroGlancer. I imagine many in the audience are already familiar with it. So NeuroGlancer has this concept of layers and can overlay any number of different sort of logical types of data on top of each other. In this case, we're overlaying an electron microscopy volume. In this case, this is a 2 petavoxel human cortex data set. We're overlaying that with a segmentation and with detected synapse locations. So NeuroGlancer will show cross-section views. You can view multiple cross-sections at a time. You can also show 3D projections. The cross-section views can actually be oriented at arbitrary oblique angles. So we can rotate these cross-sections arbitrarily. Another interesting feature of NeuroGlancer is that the rendering is customizable through these little, what we call shader snippets, using a programming language called OpenGL shader language. And that's integrated right into the NeuroGlancer UI. So in this case, we're using NeuroGlancer's capability to find these UI controls that integrate into the shader. And that allows us to do things like modify the color of a layer. We can change the min and max bounds to adjust the contrast and brightness. We can similarly use this programmability on annotations. And so here we have this annotation layer corresponding to synapses, and we have this little snippet of shader code that allows us to set the colors of the endpoint markers and the size of the markers based on, in this case, shader controls, although they can also be set based on properties of the annotations. And so we can use these controls to adjust how they're rendered. So there's obviously a lot of functionality in NeuroGlancer that I'm not going to go into now, but I was just trying to give a basic overview. And so in its sort of default use, NeuroGlancer is just a web-based application. The entire state of the viewer is encoded in the URL. And so just by copying the URL and sending that to someone in an email or chat message, they can then see exactly the same viewer state that you're looking at. Another feature of NeuroGlancer is that there's a Python API for interacting with it. And so what that allows you to do is by just installing the NeuroGlancer package from PyPy, you can fully control the NeuroGlancer state from Python. And so in one form, you can just use the Python API to create NeuroGlancer views and generate links and put those into generated documents or share them. But more generally, you can also use it in a sort of more integrated fashion where the NeuroGlancer state can be directly controlled by Python. Changes made in NeuroGlancer are reflected back in Python and vice versa. And you can also view NumPy arrays that exist in Python overlaid over other data sources in NeuroGlancer, set up key bindings and so on. So I'll give a brief demonstration of how that works. So here we'll start by importing the NeuroGlancer package. We'll create a viewer object. Each viewer object basically corresponds to a single NeuroGlancer viewer window. And by printing the object, we get a link that we can use to open it in a separate browser window. It is possible to embed the browser, the NeuroGlancer view directly in the notebook, but in most cases it's more convenient to have it as a separate window. So then we'll use the API of this viewer object to add some layers. You can see once we execute this line, immediately the NeuroGlancer viewer state gets updated. So in this case, we added a single image layer and a segmentation layer overlay. Now we'll modify the viewer state to move to different coordinates. You can again see that the NeuroGlancer state immediately updates. I will hide the segmentation layer. What we're doing here, I won't go through all the details of this, but what we're doing here is we're retrieving a portion of the same image volume that we're viewing into Python using a library called TensorStore. We'll then do some basic processing. In this case, we're just going to threshold it as an example. And then we're going to add this result of thresholding back as an overlay onto the NeuroGlancer view. So this is relying on what I said before about having an array in NumPy that we're then going to display as an additional layer in NeuroGlancer. So I'll execute this. And now you can see this thresholding result is displaying as an overlay in the NeuroGlancer window. And we can modify the thresholding parameters and update it within NeuroGlancer. So now I'll just show briefly some other functionality. So we'll again enable the segmentation layer and in this case modify which segments are selected. So now you can see these two segments are selected. So the NeuroGlancer state is actually represented as this JSON representation. And through this Python API, we can manipulate that state using a collection of Python classes. But we can also just view the JSON representation directly, which is shown here. And now we can actually see, in this case, which segments are selected. And if we select a third segment and then reevaluate this, we'd see that now there's three segments shown, sort of demonstrating the live connection between the NeuroGlancer view and Python. So we can also actually just modify the entire, reset the entire NeuroGlancer state using the setState method. What I'll show here is the ability to bind a key in NeuroGlancer and have that invoke a Python callback. So in this case, what we're going to do is bind the T key to invoke this, this Python function myAction, which will then run every time the key is pressed. And this function has access to the current NeuroGlancer state and also to the mouse position within NeuroGlancer and to the value within each layer under the current mouse position. It's also showing another minor feature, which is the ability to show status messages in NeuroGlancer from Python. So I'll execute this, and we can immediately see at the bottom of the window this status message. And then if we press the T key, we see that the callback runs because both the status message in NeuroGlancer updates, and also in the notebook, we see the output from our function. We can press it again and we get more output. And so using this type of key binding functionality, you can create various sorts of ad hoc proofreading tools or analysis tools based on NeuroGlancer for working with datasets. So now I'll demonstrate changing the view parameters from Python. And then one additional function through the Python API is the ability to take screenshots. And so, so here we'll show that, capture an image, and then we get that image back into the notebook. There's actually also, within the NeuroGlancer repository, a number of command line tools that you can use to capture screenshots and videos of arbitrary NeuroGlancer states as well. So finally, I'll show a few more features. So far, in NeuroGlancer, we've just had a single collection of layers shown, either as a single view or as a sort of 4-panel or 2-panel view. But it's also possible to show multiple collections of layers as different tiles on the window. And so here we'll so now we're showing actually 2 collections of layers. On the left, we have the image layer and this NumPy overlay layer. On the right, we have this segmentation layer. And with this tile view, they're still actually synchronized in position, although it is possible to unsynchronize them through an option. But this is a way to show sort of potentially multiple types of information or sort of more layers at a time, where it's not feasible to sort of overlay them all together. Now we'll update this layout to remove the overlay layer, and I'll demonstrate what I talked about before of using this NeuroGlancer Python API to create a URL that you can then just share as a regular URL. So that's all that I have to say about NeuroGlancer and the Python API. But if you want to find out more, just visit the NeuroGlancer GitHub repository, and you can also find more examples there and examples of the Python API. Thanks.
Hey, I'm Lars. I'm going to give a quick intro to NeuroTrALE and then pass it to Mike Snyder for a demo of some of the tools. So the goal of NeuroTrALE, it's a neuron tracing and active learning environment, and it's kind of based on the NeuroGlancer functionality, and we made some customizations and modifications specifically on the annotation layer to be able to edit the algorithm generated results to facilitate iterative machine learning development. So kind of a semi-automated way to increase ground truth data and update machine learning models directly from within the NeuroGlancer environment. So this is a kind of an overview example where, we may have a lot of raw image volumes of axon fibers or neuronal nuclei, some image processing task that we want to accomplish. We would apply a baseline algorithm and then ingest the imagery and segmentations into a pre-computed data management server that we customize to work with our version of NeuroGlancer, which is called NeuroTrALE. And then a user would be able to view the imagery and annotations in NeuroTrALE, make edits, and save back the reviewed data, and then retrain the machine learning algorithms to improve the performance of neuron detection, axon tracing, et cetera. So this goal is to enable rapid AI model development. And so, yeah, getting into some of the custom capabilities we added to NeuroGlancer, the functionality specifically was to be able to edit polygon, pointwise, and line string annotations, and be able to navigate within each annotation object. So we added a side panel for showing the hierarchy of annotations. And then there's also tools to create new annotations from scratch, and then navigate within a specific annotation object, like following an axon, for example. And so there's a few different data types that we kind of optimized for. And now I can pass it to Mike Snyder to kind of dive more into that.
Sounds good. Good morning, folks. I'll steal the screen share here. And we have a short video queued up that'll kind of narrate over, showing off the things that Lars was talking about there. So this first one, we're loading in a data set that's a human brain segmentation map. And we can see on the left-hand side, the tree view that Lars was talking about to show the hierarchy, which will expand here and allow us to navigate through and jump to the different sections that the user may want to review and correct or add annotations to. And so all of this data is being pulled from our backend JSON data store that Lars was talking about. And as the user navigates through it, if they choose to add new annotations or adjust any of the ones that are there, it'll all automatically be saved in real time so that if they reload later, all of their changes have been preserved. You can see here we've added a couple annotation types for polygons and line strings over on the right-hand side. So this is demoing just drawing a simple polygon if the user wanted to create a new region for their annotations. Or if they were working in, for example, an axon data set, they could create line strings, which are like polygons, but not closed. We've also added a few kind of editing capabilities to the annotations. So you can draw a region and then use it as a selection region to delete the portion you selected, which is what we're doing here. And then just like baseline NeuroTrALE, you can go through and delete portions that you no longer want to keep, as well as edit sections of existing annotations if you need to course correct something that you yourself did or something that the algorithm auto-detected for you. And so that's a brief overview of looking at this workflow. The next data set portion of this demo will load in some axon data, which is looking at primarily line strings. And we'll see how we can filter those and navigate through and follow along amidst sort of the sea of data there. So we can see all of the individual fibers showing up on the left or the right-hand side here. And we're turning off control points here to make the fibers a little bit easier to see overlaid on the background imagery. And then turning off the slice view in the 3D plane, we can kind of get a sense of the volume of the axons we're looking at, and then using this filter to adjust how many of the large versus small fibers we want to review, we can down select to just the really long ones. And for example, select one of the interesting fibers, which will be highlighted in yellow here, and then we can start to follow it along, either sort of continuously as sort of like an animation, or at individual steps to kind of jump to the next control point, for example. And this becomes useful when, as we'll reduce the size filter here, you're kind of amidst a sea of large amounts of data, and you want to try and follow through the imagery to make sure that your association is making sense. And all the same capabilities apply here, where the user can go through and move the control points and add new annotations to the data set as they deem fit. So the current process we're working through is we've open sourced all of our contributions, and we're working through cleaning those up to get them released out onto GitHub and introduce them back into the community for integration with the baseline NeuroTrALE.